Good morning. Hi everyone. Welcome to Gateway to Voice. Uh, Myself, Rahmathullah Khan Muhammad, CEO of Gateway to Voice. Today, I will be starting design for my CCNA and CCNP Voice lab. Uh, Here, I will be using two tools. One is GNS3, as you must be familiar with, and one is VMware Workstation 8.1. And GNS3, I will be designing my lab with the design which I will be showing in a few seconds. And the VMware, I'm using it for IP phones, where I will be installing my XP Pro machines and installing an IP phone on them, then connecting these IP phones over the network which I will be designing on my GNS3s. So let's start and look at the network design. This is the network design, where you can see as that, and I'm using three routers. There's one for headquarters, one for branch office 1, and one for branch office 2. These three routers are connected to each other via frame relay cloud. Okay, and this is a third layer switch, which I will be using it as a PSTN and switch for establishing the PSTN connections between these three routers. Okay, and here are the IP addresses which I'll be using in my network. So as you can see is that these routers are 3275 routers which are connected over a frame relays, and this is the layer 3 switch. The concept of this lab app is to run both CCNA and CCNP voice labs. Most of the, as you can see, most of the labs on this lab design, on this network design, you can say is. So the idea of this lab is to define and three organizations and imaginary organizations which have head office in London, branch office in US, one branch office in US, and one branch office in India. If they want to communicate with each other, they use the WAN connectivity in order to toll pass the PSTN charges. So once this connectivity goes down, like if there is a problem with the connectivity between these three routers, then they use the PSTN as the backbone to communicate with each other. And as you can see is that this VM1, VMnet1, VMnet1, these are the virtual machines which I will be using, and you can see is that the internal, if I'm calling over the WAN and from head office to branch office, as I use the extension of 3EXXX, which means I can have 3001 or 310, any combinations. But if I'm calling over the PSTN connections, then this is the number which will be displayed on the IP phones. Okay, so it's a basic design, and with the in-depth knowledge of not in-depth knowledge, a basic knowledge of frame relay concept. I will be designing this network in GNS3. So let's start focusing on the design. And okay, as you can see is that I have opened my GNS3s, but make sure that you run GNS3 with administration mode. If you don't run with administration mode, you won't be having the networks configurations. You find it difficult in configuring networks on the cloud part. Okay, so let's start with the network design. As I says that I will be using 3725 routers. So where I will be using the iOS of Advanced Enterprise Edition K9 MZ 12415 HTB8 images. Same for the branch office as well. The only reason why I'm sharing this knowledge with you, with others, is that I always think that sharing knowledge is the key to success. So as you can see, I have defined a frame relay switch, which is good in GNS 3. But if you want to configure your own frame relay switch, you can use 29 and 69 routers and configure the frame relay statistics on it. But for this lab, I will be using frame relay switch. Let's start configuration. Start with configuration of this frame relay first. Click on configure, goes to frame relays. Here, before I start configuring, I want to say is that I will be configuring the frame relay at the point-to-point interface, where I will be having two DLCs here, one DLC here, one DLC here. One, if I want to communicate with router 1, if router 1 to communicate with router 2, it has to use the DLC 102 to communicate with router 2 is 201 DLC. Okay, and the same goes with here as well. As you can notice that the use of point-to-point frame relay is that you can utilize to have a good connectivity, but the only problem with the point-to-point connection is wastage of not wastage, it uses different IP addresses. And one more advantage of point-to-point is it utilizes as the whole range of IP address which you are defining. But whereas if you define and this in a multi-point and range, it will be using the whole range of IP addresses. So router 1 communicate with router 3, I used DLC 103 on router 1 and 301 on router 2. Okay, so keeping in view of this design, like parameters, let's start configuring the frame relay. Okay, first click on right click on frame relay, goes to configurations of frame relay. You find it's a port 1 with DLC 101, change it to 102, which means port 1 having the DLC 102. Okay, port 2 having DLC 201. That is, if port 1 wants to communicate with port 2, it uses these DLCs. Okay, and same goes with communication between router 1 and router 3. Okay, but the only difference is instead of port 2, I use the same port to communicate with router 3 with DLC 103, and port 3 to communicate with 301 DLCs. So add these DLCs onto frame relay. Click on OK. Now that you can see is that we have configured the frame relay. The next step is to configure the routers. Before we start connecting the routers, make sure that if you have a WIC slot available. Okay, so I'm using WIC 1. Same goes with here as well. WIC 1. Okay, so you have all the serials connected to be configured on the routers. Then start the connectivity between these ones. Okay, I use serial 00 connect to DLC 1. Okay, DLC port 1 on frame relay. Okay, router 2 00 used to connect to port 2 .00 used to connect to router 3, which means once that now we have connected routers with to the frame relays. As you must be knowing that if you are connecting the serial ports between two routers, as one router needs to be configured the clock rate, but whereas in frame relay terminology, frame relays will provide the clock settings to the routers, so no need of configuring the clocks on these three routers. It will be configured on the frame relay. So once this configuration, once they are connected, now let's move on to configurations. Before we start configuration of these routers, let's start these routers. As you can see, as that the routers are started. So let's start with the configuration of router 1. So right click on it, goes to console. It will take you to the console prompt. Okay, type E and enable, then goes to configuration mode. Define the host name first, which is HQ office. Okay, as you must be knowing that we have configured the connection of frame relay and router 1, which is a headquarters router, over a serial interface. So goes into the serial interface. Okay, since we are using on the technology which we will be using on the frame relay is called encapsulation, frame relay technology. So goes to the physical interface, as since we will be using the virtual interface to connect to the frame relays, go into the physical interface, type no IP address, okay, and no shutdown. Okay, the link that comes up, goes to encapsulation, type frame relay. Okay, which means that we are running a frame relay protocol on this. Okay, go on to the exit, goes into the sub interface 102. I will be giving it as 102 since I'm connecting router 1 over the frame relay to 2. Okay, then if you press question mark, you can see we have two options. One is point-to-point connections, and other is multi-point connections. So as says that I will be using point-to-point connection here, point-to-point connection. Okay, to define the IP addresses, as you must be knowing that the IP addresses which I have defined when I showed you the design of my networks. Okay, so 10.123.1 with 255.252/30 IP address. Okay, click on enter. Okay, once we have defined the IP addresses on the sub interface, the next step is to define the DLCs. Like, in order to know the router which DLC it should use to communicate with router 2, we need to define the DLCs. So go into the frame relay. Okay, interface frame relay interface DLC. Okay, type the DLC number as 102. Okay, same DLC which we have configured. Okay, goes to exit. Okay, now that we have configured one sub interface, let's start configuring the next interface. Go sub interface 0/0.103. okay, which is the point-to-point connection. IP addresses 10.10.123.5. I will be using is 255/30. Okay, Same goes here as well with frame relay interface DLC is 103. Like that. So now that we have configured the sub interfaces on the router ones, let's see how it looks. So type show run frame relay. So show frame relay maps. Okay, there you can see that I'm having two sub interfaces, one called 102 and one called 103, which are point-to-point connected over DLC 102 and the broadcast. Here you see is the status is active, yeah, which means that the connection from router 1 on sub interface is active, but in few minutes or few seconds it goes to inactive, since we have not configured this frame relay on the other side of the routers. Okay, now that we have configured the headquarter routers, let's start configure on branch office 2 routers. Okay, same goes here, goes to config t host name. Okay, branch 1 office. Okay, goes to virtual interface, type the same commands, no shut with no IP address, and encapsulation frame relay. Okay, go on to the exit one step back, go into the sub interface, and here I will be using 201 DLCs with point-to-point connections with IP address 10.10.123.2. I will be using with 32-bit mask. Okay, with frame relays interface DLCs 201. Okay, I'm going to exit, exit. Okay, so let's see show frame relay map. Frame relay map. Okay, there you see the status is deleted. So it takes time for frame relay to configure the DLCs. Is deleted means there's a problem on the other side. Yes, right now you can see that the interface serial 00 is up, and now if I check, still deleted. Takes time to configure it. Okay, let's see on the other side of this headquarter router. It says actives. It's taking time. By the time it comes up, let's configure the other router, which is branch office router. Goes to 150 terminal. Okay, config terminal host name br2 IC office. Okay, so goes to serial interface 0/0, no shut, no IP address. Okay, IP address goes to exit, goes into sub interface 301 with point. Oh, sorry, haven't configured encapsulations. Okay, encapsulation frame relay. Okay, goes to exit. If you don't type encapsulation frame relay, it won't allow you to go into the sub interfaces. Okay, IP address 10.10.123.5 with 32-bit mask. Okay, and frame relay interface DLC 301. Okay, I know it's a bit annoying. One of my my colleagues are having some construction in the house, so I know it's a bit annoying. Okay, so exit, show frame relay map. It's active here, you can see it's active. Okay, let's go to the router branch office 1 and let's check. Now you can see it's active. You see, active. Okay, so let's ping on the headquarters IP address. Yes, successful connectivity. Do the same with branch office as well. Ping 10.10.123.5. Okay, 5. Okay, now that we have a successful connectivity between these three routers, like not successfully, partial mesh connectivity, ping 10.10.123.2, connection to router 2, connection to router 3, successful. But if you ping from branch office 1 to branch office 2, it won't ping. See, 3.2. Oops, sorry. Branch office 2. Yeah, from branch office 2 to 1. See, there's no connectivity between branch office 2. Oh, one second. Yeah, as you can see is that I can't able to ping 10.10.123.2, which is as branch office 1 IP address, since it's a hub and spoke network, wherein branch 2 doesn't know the can't reach branch 1. So there are two ways. Either you can configure a static route between these three between these two routers, or go with any type of protocols, like EIGRP or OSPF. But in my okay, so the router branch 2 router can't reach branch 1, but whereas the headquarter can reach both the routers, which is 6. Sorry, it's not 6. Show IP interface brief. Okay, so they are up. You can see this physical rate is up. Okay, so can I ping 123.2? Yes, successful. Can I able to ping 123.6? Oh, there is a problem with branch office 2. Okay, let's see. Show IP interface for this. Show IP interface BRIF brief. Okay, everything is up. Oh, the problem is here. You can see that I have configured the IP address here wrong, which is 5. It should be 6. Okay, so let's change it quickly. It goes to sub interface 301. IP address is 10.10.123.6. so 123.6. okay, 255, 252, 30-second mask as control set. Okay, so it's not compulsory, but I usually do is I shut down this physical interface, then I type no shutdown. Okay, it's up. let's check. Bingo, there is a connectivity between these. Okay, so in order to establish the connection between all the three routers, let's use as a routing protocol. Here I will be using OSPF. So go into configuration mode, type router OSPF 1. Okay, sorry, OSPF1. Okay, so it gives the network as 10.10.123.0. Since I don't want to use the whole range of 10.10.10 and networks, I will be using a wildcard entry with area 0. Okay, same goes with here as well. And branch 2 config T router OSPF1. Okay, goes with network 10.10.123.0 0.0.0.255 area 0. Okay, as soon as I type that one, there you says adjacencies, that is the neighbor relationship found between these routers. Okay, let's do with the branch office one as well. Goes to config T, goes to router OSPF1. Okay, type network 10.10.10.123.0 with wildcard mask area 0. Okay, as soon as I type this one, there you see all the three have neighbor relationship. Okay, so let's go on to this router. Okay, I will show you the command show IP OSPF neighbors, which used to configure the neighbors. There you see as there are two neighbors for headquarter routers. One is 2 and one is 6. Both are in full state. If they are in initial state, it will show the stage. Okay, as you must be knowing that there are 4 stages while OSPF is configured. One is init stage, 2 is stage, loading stage, and then full. Okay, now that the connection between these 3 routers are done, let's ping from branch office 2 10.10.123.2, which is branch office 1 and IP address. Okay, before we run OSPF routers, you see that there was no connectivity between router branch office 2 and branch office 1. Now that we have configured OSPF routing on all the 3, it should be connection. Bingo, there you see connection between router 2 branch office 2 and branch office 1. So we have successfully configured the frame relay cloud, okay, between these 3 routers. So I don't want to fit all in one video. I will be breaking this video into different parts where you will be having ease of doing in this lab. Okay, thanks for watching me, and I will see you in next video.